Welcome to qnawire.
Hi, so in this case we are going to look at the atomization of benzene. We have C6H6 as a gas that is going to produce 6 moles of carbon gas plus 6 of hydrogen gas. And we're going to find the delta H for this reaction using two methods. First of all, delta H with bond energies, and then delta H using Hess law. So for the first method, I'm going to do it in red. For method 1, the delta H for the reaction in terms of bond energies is equal to the sum of the bonds broken minus bonds formed. In this case, no bonds are being formed. We're only going to have bonds that are being broken. So in this case, the delta H is equal to, remember that the benzene molecule looks like this. We're going to have 3 double bonds and 6 carbon hydrogen bonds. So it is going to be 3 times the carbon-carbon energy plus 3 times carbon double bond carbon energy plus 6 times carbon hydrogen energy. So looking these energy and tables, they correspond to carbon-carbon is 348 kilojoules. Carbon hydrogen corresponds to 413 kilojoules. And carbon-carbon with a double bond corresponds to 614 kilojoules. So the delta H for this reaction is equal to, using the first method, 5,364 kilojoules. And just a small correction here, while I was talking, I switched up the values, but the first one corresponds to carbon double bond carbon, and the second one to carbon-carbon interaction. Perfect. So now, we're going to follow up with the second one that employs Hess law. So for the second method, what we're going to do is, let's write down again our reaction. Gas plus 6 hydrogen gas. And the delta H for the reaction, according to Hess law, it's going to be equal to 6 times the delta H of formation of carbon as a gas plus 6 times delta H of formation of hydrogen atom as a gas minus the delta H of formation of benzene as a gas. Now, the values that I'm going to be employing are from Overby and Chang. The delta H of, and it's from Appendix 2. So you can replace the values with the ones that are given to you in your book or the table that your professor provided to you. In the case for benzene, the enthalpy of formation is 49.04 kilojoules. In the case for carbon as a gas is, actually let's go first with hydrogen gas. For hydrogen as a gas is equal to 218.2 kilojoules. And finally, now for carbon as a gas, the value corresponds to actually, I didn't find this one in Overby Chang, but I found it in the Argonne National Laboratory active thermochemical tables, and the value is 716.89 kilojoules. Gives us a total of 5,577.6 kilojoules. Now, why do we have such a large discrepancy between these two values? Well, as you can verify, the discrepancy is of 200 kilojoules per mole, and this is because we have to take into account the aromaticity of benzene. So employing the bond energies directly without taking into account the fact that this compound is stabilized by aromaticity is not going to give us the correct result. And in this case, you can see that the comparison is up to 200 kilojoules of difference. And that would be all. Thank you very much and have a good one.